Alright everybody, welcome to the video notes for section 7 for Algebra 1. This is the basically the exponents unit, and we're starting off with section 7.1, which is basically exponents involving products, which basically means just multiplication and all that good stuff. Alright, so kind of moving forward here, so simplifying exponents out. Just this first slide, I'm not going to spend too much time on this, just kind of a base demonstration of this. So, we know that, so when dealing with exponents, just a little bit of terminology here, the big number, basically the number that, we're multiplying multiple times, that's the base, all right? That's what we call the base. And then the little number, the amount of times we're multiplying that number, that's the exponent. So again, we all know that, 2 to the 7th power is essentially 2 times itself 7 times. 1, 2, 3, 4, 5, 6, 7. Okay, which again is equal to 2 to the 7th. And you can figure that out in a calculator. 2 to the 7th power. It's going to give you some big number. Blah blah blah. So just a couple quick examples down here. Let me see if I can. Actually, I don't think I had that. Oh, no, never mind. So just a quick example. Example 1. Okay, 7's the number that's being multiplied, so it's going to be 7, and the number times it's multiplied, 1, 2, 3, 4, 5, 7 to the 5th power. Over here, 3 is the number that's being multiplied, 3, and then 3, 1, 2, 3, 4, 5, 6 times, okay? Now, example 3, there's a couple different ways we can look at kind of grouping those together. We can basically we can group the 4 x's all together and kind of do it like that, or we could literally just do it all kind of separately. Oh, once again, I'm going to just group them all together, and again, if you group them all together, you basically group the 4x into a parenthesis on its own, and then you basically count how many times you have it. So 1, 2, 3, it just turns into 4x to the 3rd power. If you want to do it all individually, you can do that. You just do 4, 4, and 4. That just turns into 4 to the 3rd power, and then x, x, and x to the 3rd power as well. And I'm going to skip example 4 again, kind of because it's going off the screen here. So now what would happen if we essentially took a base, say 2 bases, with the same exponents, with the same bases, and multiply them together with different exponents? Well, if we drew it out here, 2 times 2 times 2 times 2 times 2, that's 2 to the 5th power, and then multiply that by 2 times 2. Now again, this is all just multiplication, so we're basically going to do this by 2 times 2 times 2 times 2 times 2 times 2 times 2. And again, as we did in the previous slide, all we really do when doing the exponents is count up how many numbers of times that you multiply together. So how many 2's do we have here? Well, I have 7. And if we notice these exponents here, 5 plus 2 equals 7. If we do the same idea over here, you get x cubed, that's just 3 x's, times 5 x's, which is 1, 2, 3, 4, 5. You count up how many x's you have, 1, 2, 3, 4, 5, 6, 7, 8. X to the 8th power, and hey, look at that, x3 plus 5 equals x to the 8th, all right? So that's the product of a power property, all right? When you multiply the bases of the exponents, you have to add, and it kind of says, it's a little off the screen there, so I apologize, but you have to add the exponents. All right. So again, fairly simple enough. Now let's go on to something different here. So this is what we consider a power to a power, okay? And the way that you'll notice these is that these problems or these types of examples are always going to have parentheses, right? So that's kind of your first clue, is to look for parentheses. But so let's just kind of start with let's actually figure out what 2 to the 4th power to the 2nd power is actually telling us, all right? So if we got 2 to the 4th power, that's 2 times 2 times 2. And what does squared mean? Well, squared means that we basically take whatever's inside here and multiply it by itself again. So if I have 4 2's inside, I'm going to and it's squared, I'm going to basically take another 4 2's and multiply it again. And if you count them up, again, I'm just counting up how many 2's I have here. I will get 2 to the 8th power. Now, if we notice the similarities, 4 and 2, It's not 4 plus 2 now, it's 4 multiply times 2, all right? So again, if you have seen those parentheses, instead of adding those numbers, you're going to multiply those numbers, okay? Now for this one here, I'm going to kind of write it out here. So I'm going to write out what I have inside here. So 2 times x squared, which is just 2x's, times y. And then it basically wants me to write it out 5 more times, and that's, that's quite a lot there. So, but basically what that means is, it wants me to multiply 2, 5 times, and then it wants me to write 2 other x's, 4 more times, like 1, 2, 3, 4, 1, 2, 3, 4, 5, yeah, and then 5 y's, all right? So it's basically just rewriting all this stuff, 5 times. Now if we look, 2 times 2 times 2 times 2 times 2, that gets us 2 to the 5th power. And if we look at all of our x's, we count up all of our x's, we get x to the 10th power. And if we count up all of our y's, we get y to the 5th power. And then we could simplify 2 to the 5th as just 32. Now this is, kind of an extension to this upper one here. Instead of just having, one base with one exponent, we have multiple bases now, with multiple exponents. If we have those multiple bases, what we're going to do is we're going to distribute, and I'm going to use like air quotations when I use this, distribute this power as a power to every base in there, all right? We're not now, when we do 5th power, this 5 to this 2, we're not going to multiply, just write it up here, we're not going to do 5 times 2. We're going to do instead just 2 to the 5th power. Again, we distribute it like a base. And when we distribute like a base, we just multiply, all right? So 5, and again, if there's no exponent there, then, well, you're basically just multiplying this exponent by 1, you get the 5th power. But again, as we did this 5 to the 2nd power, x2 times 5 got us 10 over here, okay? So again, that is the power of a power property, all right? It's basically when you raise a power to a power, you have to multiply basically the numbers in the exponents. Just say and I'll write exponents, all right? Okay, so let's work out a couple examples here, all right? Just work out a couple examples. So example number 9, I got 3 times 3 to the 4 times 3 to the 2nd. Well, again, I am basically just multiplying these bases here. I don't see any parentheses, so all I need to do is add these exponents here. I'm going to keep the base the same as 3, and I'm just going to add the exponents. 3 to no power. Again, this is something kind of important here, but if you have a base, whether it's a number or even a variable, like we get down here to example 11 or 10, if there's no exponent there, we treat it like it has an exponent of 1, right? We don't treat it like an exponent of 0, we treat it like an exponent of 1. So all we do there is we just add the exponents together. So it's just going to turn into 1 plus 4 plus 2, which just gets us 3 to the 7th, which, pull up a calculator here. If we do 3 to the 7th in a calculator, once I finally pull it up here, oh, there's 3 to the, it's going to get us 2,187, okay? Now this one, for example, 10, all right? Now, I have this 5 and this 2 right here, but I can't add these exponents together. So this is technically 5 to the 1st power and then 2 to the 4th power. I can't add those exponents together because these bases, the 5 and the 2, are not the same. So we can't add the exponents together, but what we can do is we can simplify the numbers out as they are. So 5 to the 1st power, that's going to be 5. And I'm going to find out what 2 to the 4th power actually is without any exponents. So just kind of quick here, 2 times 2 times 2, it's going to turn into 16. So if I simplify all this out, I get y to the 3rd times 16 to the y 2nd. And then from there, what I'm going to do is, if I have, now once I get my numbers in front here simplified out to where they don't have any exponents, now I can just multiply them like regular numbers. Again, everything up here is essentially multiplication. So I can just multiply these two numbers together here. 5 times 16 gets me 80. And then I combine my y's. Now I have similar bases, 2 y's and 2 exponents there. Again, I add those exponents. 3 plus 2 gets me y to the 5th power, okay? All right, all right, all right. So, move on to example 11 here. I have x. I'm going to put, you don't have to do this, but I like putting x to the 1 power if there's no exponent there, just, so it's a visual that you remember that number instead of, forgetting to add that number. So we're just going to try and simplify out xy cubed times y to the 5th times x squared. Okay, start with this x here, all right? Do I have any other x's? I can't simplify it with this y or this y because they're different bases, but I have this x right here that I can simplify it with. And again, if I do x times x squared, again, all I'm doing is just adding these exponents here. x1 plus 2, that'll get me x to the 3rd power. And then that's my x's. I move on to my y's. Y to the 3rd power times y to the 5th. If I add those two exponents together, I get y to the 8th power. All right. Moving over here, let me change that with something here. So, example number 12. Now, this one's a little differently. I have a set of parentheses here. And again, just as we have done, with linear equations in the past, if you have something to distribute, get rid of that first. So what I'm going to do, I take this power, distribute it as a power to everything inside. So what it's going to become is 2 to the 3rd power, x, and then I'm going to do 3 times 5, which becomes x to the 15th power, and then y to, well, just turns into y to the 3rd power. Not done yet. I still have this x cubed and y to the 4th on the outside that I need to simplify. I'm going to simplify this x with this x here, x to the 3rd times x to the 15th. Now I'm back to just straight up adding my exponents, so it's going to be x to the 3 plus 15, which is x to the 18. And then I'm gonna simplify these y's here, which again turns into, I'll write it over here, y to the 4 plus 3, which is just y to the 7th. And then 2 to the 3rd power is just the number 8. I don't have any other numbers that I can multiply that 8 by, so that's basically going to be the final answer right there. All right, example number 13. We got a couple things of parentheses, so I'm going to have to do a little bit of distributing here. So first of all, take this 2, distribute it as a power to everything. Make sure you also include that number out in front. There's a lot of times people will forget that. So make sure you do it to everything here. Sorry about the bell in the background. So we distribute it as a power there. I get, let's see, distribute it out there. I'm going to get 3 squared. Distribute the 2 to the x. It's going to be, it's going to write it up here now, x squared. Distribute the 2 to this y. That turns into y2 times y2. That turns into 2 times 2, which is y to the 4th. And then what I'm going to do is with this one, distribute this 3 out here. So it's going to turn to 2 to the 3rd power, and then 2 to the 3 times 3, which is just 2 to the 9th. And then x, distribute that 3 there, that turns into x3, and then times that y there. All right, now I got to simplify everything out, so I'm going to bring it up here. First off, I'm going to simplify those numbers out just to, because we don't have the same bases, so I can't add the exponents, but I can simplify those numbers out and multiply. So 3 squared is just going to be 9. I'm just going to rewrite x2, y4. 2 to the 9th power, let me just redo this here. It's going to give me 512, so it's going to turn into 512 x3 times y. Oh, went a little bit too far there. All right, and then from there, I'm just going to simplify out. First of all, I take my numbers, and I'm just going to straight up multiply them. Straight up multiply. 9 times 512, which gives me 4,608. And then I start combining my x's. So I got x2 times x to the squared times x cubed. All I do is just add those exponents, so it's going to turn into 2 plus 3, which will give me the 5th power, so it's going to turn into x to the 5th power. Y to the 4th times y, which again is just y to the 1st power, which again turns into y to the 5th, because again, all I'm doing is just adding 4 plus that 1, gets me that new exponent there, all right? All right, I have run, and this is my final answer. Just make sure I circled that there. All right, I have run out of time. I don't have enough time on the recording to finish out example number 14. If you want, I can make a separate video of that, but other than that, these are basically the 7.1 notes for you guys. I will get the 7.2 notes up very soon. Thank you.